So on that first one, if x is -1, what is y? If x is -1, what is y, Natalie? Natalie says -5. Is she correct? I heard somebody say how. Well, what is 2 times -1? -2. What is -2 minus -3? Do we subtract? We add opposite. So -2 plus -3 is -5. If x is 0, y is, what's it going to be, G? -3. If x is 1, y is, Ty,
0.
he says 0. Is he correct? Well, I'm thinking 1 times 2 is 2 minus 3 would give me -1. I'm not thinking, okay? And if x is 2, y is 1. Correct? No, it's, yeah, I'm right. Okay? What about the second one? Okay? What's the second one? Give me the different places here. Miss Shelby.
All of them?
Yeah, just give me all of them.
-1 is 2, 0 is 1, 0, 1.
Do you agree with Shelby? Is she right?
No.
Okay, let's take a look. The opposite of
I did not
x.
do that. I said
Okay, so this one here,
2. So
opposite.
-1 is 2, 0 is 1, 1 is 0, 2 is 1.
okay, you said this is 2,
1,
1, 0, 1.
Okay.
Now, do you agree with Shelby?
No, I have
Okay, let's stop. The opposite of x. Well, here x is a -1. What's the opposite of -1? 1. So 1 plus 1 is 2. I agree with that one. The opposite of x, if x is 0, it doesn't really matter. 0 is 0, right? So I agree with that one. If x is 1, that's the opposite of x. The opposite of 1 is -1 plus 1, so that's 0. And if x is 2, the opposite of that would be -2 plus 1 is a -1. Okay? Okay. What about number 3? What about number 3, Miss Lindsay Ridley?
I
There's one.
have 4, 5, 6, 7.
5, 6, and 7. Is she correct? -1 plus 5 is 4. 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. I totally agree with that one. Madison? Uh-huh.
I have 1 and 1/2.
Okay.
2. 2 and 1/2. And 3.
Do you agree with her on that one? Okay. While I was gone, you did an activity where you drew the puppy dog. Bowser, was that his name?
Mm-hmm.
Huh?
It don't look like it does.
Oh, it looked wonderfully like a dog when it was done properly. And I will tell you that I gave you a completion grade on that one. This one's kind of struggling to look like that dog. He's kind of there, but he's not quite all the way.
Don't worry.
This one, Bowser's looking pretty much like the dog there. Yeah.
I just
I messed up the
Should have looked something like that. Here's another one. Mr. Bowser.
Laugh, laugh.
Okay? He's done really well. All right, so, but in order to graph those, you needed 2 points. You needed an ordered pair. Okay? Now, with these function tables, do you have ordered pairs that you could graph if you wanted to? Sure you do. And that's what we're going to be doing, but you know what? That takes a little bit of time. There are ways that you can graph it and not have to use a function table at all. And that's kind of what we're going to be working with here, okay? All right. Copy and complete the table and plot the 2 points. You don't have to copy it. We've done some of that. Now, how do you know what values for x to plug in? Does it matter what values you plug in? What do you think? Madison? Why do you choose 0 and 1? Keep it simple. Make it as easy as possible. Okay? And I only need 2 points. Well, in this particular one that we've got up here, on that first one, if I plug in a 0 for x, she says use 0 and 1. Okay? If I plug in the 0, 4 times 0 is,
0.
and we'd have a -2. Do you agree? Okay? 1 times 4 is 4, minus 2 is 2. Can I graph that one now? Do so, please. And if I do, I'm gonna. Yeah, do we need a ruler to be able to make these graphs correctly? Yes, we do. We're not freehanding, we're doing straight edges. Good question. It's harder on this than you think. Okay. Does your line look something like that? On your line, you want to make sure that you give it an extension so that you know where it's crossing both the x and the y axis. Okay? You also want to use your line symbols, meaning that you want to make sure that you've got your arrows at the end of your line, and you need to identify 2 of the points. This type of work can add up to a lot of points really fast. You had to finish out the table, that's 2 points. You had to draw a line with 2, so you're looking at 5 points right there. Because I want to make sure that you do it right. Extend that on it, okay? line on both sides. Okay, don't just stop there at that point, because that's, you need to extend it on out. Okay, good. Some of you have already done the second graph. What numbers do you want to pick for the second graph? What numbers you want, Joey?
1 and 2.
1 and 2, works for me. -1 plus 5 is 4. -2 plus 5 is 3. Okay. I saw a lot of you had lines that were going, as I'm looking, have a line that's going like this. I don't think that's going to work for you. Because if I change, I'm going to put a different color up there. If I find 1, 4 on my graph, here's 1, 4. Everybody agrees with that? And 2, 3. It's going to go the other way. Yeah, it's a negative slope. 2, 3. There we go. Mess that up. There we go. So I've got 1, 4 and 2, 3. Okay, do yours look like that? Okay. At what point, look at your first one, at what point does it cross the y-axis? At what point on the first line that you drew does it cross the y-axis? Where's it at, Joey?
1.5 and 2.5.
No, shouldn't be. Shouldn't be with, we have 0, -2, and 1, 2. So at what point is it crossing that y-axis? I know you got it, Madison. I want to see what other people find. Look at your graph. Where did this one cross the y-axis? Where's it crossing at there, Kaden? -2. Isn't this the y-axis, the vertical axis? Isn't it right here at -2? Okay. Where is it crossing on the red graph? If x is 0, at what point is y crossing that axis? If x was 0, where's it going to cross there? Ty, where's it crossing? If x is 0, it's crossing at 5, I agree. There's your axis, that's your cross right there. We said it crosses at what here? -2. And we say the other one is crossing at a 5. Did it give us those points in our equation? It did. Because there's a standard equation that says y equals mx plus b. The b is this 5 right there. Y equals mx plus b, and that is your y-intercept. That is something you want to pay attention to, something you want to know. Because if I know where the y-intercept, could I forget the table and go and put a dot right there if I wanted to? It's going to give me 1 point, but I know it has to go through. Kind of a little hint of where we're headed. Okay, and I see some of you writing it down, and that's good. It's an interactive class. It's really good to take the notes. Okay, a linear equation is an equation whose graph is nothing more than a line. It is a linear equation if the graph is aligned. Now, if the graph did something like this, would it be a linear equation? If my graph looked like that, no, it's not a linear equation. You're gonna see some down the road that is actually gonna graph like that. Would that be a linear equation? No, it would not. It's not a line. Okay? It is not a line. So these are not linear, would not be a representation of a linear equation. Okay? Every point that's on the line is a solution to that equation. If we go back to where we were at here, every point in this that's on that line would be a solution to this second equation. Well, I've got a point here at, and the drawing's a little bit off. What if x is 4? This one's not quite showing it exactly right. Do I have a point there that should be at the 1 here? There. If x is 4, is y going to be 1? That's the line tells me it is. We'll test it. What is negative 4 plus 5? 1. Well, if x was 3.5, could I estimate where my point's going to be? Is it going to be right about kind of in the middle there? So maybe about, what would that be? About 1.5? Well, if x is 3, and this graph is kind of a hard one to see it on because it's hard to get it exactly where you want it. If x is 3, y is 2. I agree with that. But if x was 3.5, what would y be? If you calculated it. What's negative 3.5 plus 5? Come on, people. What is negative 3.5 plus 5? Not 2. Can't be.
1.5.
1.5. Is that about where that comes through there? Okay. Every point that is on that line is a solution for that equation. Okay? You can use a graph to show the solutions of a linear equation. The graph below represents the equation x plus 1. Okay? X plus 1, is it crossing the y-axis at the 1? Hello? Yes? Okay. Okay, here's what you're going to do. You need to graph this. Create and complete the table. You're creating a function table.
We just make our own.
Actually, it's made there for you. You get to graph the points and draw a line. You get to plug in the values of x. So f of x. Sometimes you will see on a ACT, it'll say f of x equals 2. The function of x is 2. So what it's telling you is x is 2. I had somebody take an ACT just recently, and this was an area that they were struggling because we hadn't really talked about it. And I don't really talk about function tables that much, and so after seeing that, I realized I need to tell you, these are function tables, so that you know what they look like. Okay? So if x is 2, and you plug it in, negative 2 times 2 plus 1, what do you end up getting? What do you get there? Negative 3? So my pair is 2, negative 3. Pick another one. 0 is always a good one. X is 0. 0 plus 1 equals 1. So my pair is 0, 1. Can I graph it as long as I have 2 points? Sure can. So if I've got 0, 1, one at -2, or at 2, -3 for mine. Oh, no. 2, -3. No, it's not lining up. And 0, 1. Okay. Does your line look something like that? If you look on your line, is 0, 1 a part of your line? Is 2, -3 gonna be a part of the line that you have drawn? You have not drawn a line, so you can't tell,
My line is a little.
but you can see it. When would they ever use some type of a line like this? Why would they ever do something like this? To compare something, okay? To see the growth in something. Politicians use graphs that look like this all the time. Why do they use graphs? Why do you think they use graphs, Joey?
Like for votes?
Could be for votes, One of the biggest thing that our country wants to graph is the economy. The number of people that are out of work would be one of them, and so they make a picture. You know, they say a picture is worth 1,000 words, and the American public will look at a picture and they won't read the article. Okay? There are ways, and I think we've talked about it before, there are ways that the government can make you think things, have the exact same data, but depending on what they want you to think as to how they show it on the graph. Okay? If you've got a really big graph, like right now, these are small graphs. And so we're going up by 2. Or every one is worth 1. Do you agree with that? Every one is worth 1 point. But if it's really big, like maybe I need to start my graph at 15 million. Are they going to want to show 0 up to 15 million, do you think? No. And so what you'll see in a graph is you'll see a breaking line, a little squiggle there at the bottom, and that says I'm skipping from 0, and my first line here is 15 million. I'm skipping that. Okay. Now, and we're going to need to get on Chrome's later, not today, but we will be getting on Chrome's because I want you to see what happens when you have the same data graphed and you change the numbers on the axis. How that can change the way it looks. It can skew the data to make it appear better or worse depending on what they want you to see. Okay? And a smart consumer, if you understand graphs, you can look at it and see what they're really doing. But if you don't pay attention to that, they can make you believe something that is not true. Okay? They can make you believe the economy is way better than it really is, but you're just looking at a graph and, hey, that looks really good to me. It's just a picture. Pictures are easy. Okay? Graph this one. Y equals 3x. Do you know where it's going to cross that y-axis by looking at that? Where do you think it might cross the y-axis?
At 0.
At 0. Why?
Because you are adding anything, so the y-intercept would be plus 0.
Yeah, you could say plus 0 and it wouldn't change it at all. Very good. talk about it, because that's just learning how to do it. Thank you. If there's one, there's two, always. Okay, so what do we do? This is the equation, 3x, and that's what you put in here. Okay? Now, so we could say if x is 0, just put a 0 there. What's 3? And here you're writing in 3 times 0. Because we're just substituting it in. Okay? And 3 times 0 is, okay, so that's your y. So there's your ordered pair first, 0, 0. Okay? Okay, now, pick another number. Keep it simple. Okay? So now it's 3 times 2 is what you write there. Okay, don't use your comma, honey. It's an equation that you're writing. Okay, babe? Okay, so 3 times 2 is? 6. So what's your ordered pair?
36.
It's here.
2, 6.
Yeah. Now, can you graph these two ordered pairs on your graph?
So like 0,
0, 0. And then
you go over 2 and then go up 6.
Okay, and put a dot there. And then you draw a straight line from here to here, extend it on. Extend it. You want to be able to see what happens before and after. You're going to keep that line going. There you go. There you go. Now, put your arrows on both ends. Okay, now one thing that will help you too, so you don't have to do this, is if you count over and you say, okay, well that's 2, and that's 4, and this coming up is 2 and 4, so you don't have to count it again every time you put a dot. Does that make sense? Okay, so that is your graph, and then you would label both of the points that you graph. Okay, are you good? Okay. All right, one thing I've noticed, sometimes people want to, let me see if I can get this bigger. I think I can. No, let me see if I can turn it. There, got it bigger. Some people sometimes want to be able to put their numbers like in here, in the middle of the lines. When you're graphing, you've got to use the lines that are there, not in the middle, okay? That won't work for you. So this is 1, 2, 3, 4, okay? And you don't have to number every line. You can skip count and every second one. That way you've got a little bit more space. That's fine, okay? All right, in this one it was 3x, right? So what did you choose for an x value? What did you choose for an x value? Well, I see a number there. What number are you choosing? 2, okay. So 3 times 2 equals what? 6. So my ordered pair is 2, 6. Okay? Give me another one. What did you choose, Annie? 0. So 3 times 0 equals 0. So the ordered pair is 0, 0. Do you agree with that? Now I go in and I use what I call these crosshairs. How many of you hunt? Anybody hunts or play video games where you're shooting? Okay? And you know there's a crosshair on your scope? Thank you. Okay? That's what you're looking for, is the crosshair of the graph. So if I'm looking at a graph at 0, 0, I've got one here at 0, 0. My second one is at 2, 6. Well, here's 2 and up to 6. Okay? I've got my points where they need to be. All I need to do now is put the line in. There we go. And I've graphed it. Okay? always make sure that your points are in the crosshair. This one here was 2, 6. And this one here is 0, 0. Do what? You didn't go through what? Well, then that's your line that's not quite right. Okay? If it didn't go through 0, 0 exactly, it's because your line's off just a little bit. All right? Because if 3 times 1 is 3, it had 1, 3. Do you agree? 3 times 2 is 6. 0 times 3 is 3. So it would have gone through if you'd have had an exact. Okay? All right, what do you do when you got a fraction? Is there anything you can do on a fraction that, I mean, do you want to graph half points? I mean, it's okay if you want to. Could I do something to that fraction though and not ever have to even think about the fraction part of it? Yeah. This decimal would work, but isn't decimal still going to have a 0.5 drawing somewhere? I could make every line worth a half. Okay? So I could say this is 1, this is 2, and this is 3 out there. I agree with that. Okay? But then you're going to have, if you say your number you choose is, how many of you would choose 0? I'm going to choose 0 every time. Every time. Because -1/2 times 0 is always going to give me, oh, it's plus 2. That's going to be 0 plus 2 is 2, right? So I've got a point at 0, 2. I am always going to choose an x value of 0. Always. Just because it's easy. Just because it's easy. Now, if I choose an x value of 1, do I have to work with the -1/2?
Yes.
Okay. What if I chose an x value of 2? Would I have to use the -1/2?
No.
Because isn't -1/2, and Shelby said it, we talked about that reciprocal, times 2 over 1, isn't that going to be -1? So does that take the half out of that for me, where I don't have to deal with the fraction? What if that fraction was 2/3? Do you want to graph or add and subtract? See what I'm saying? So if you look at the fraction and you always choose a multiple of the denominator, you can eliminate the fraction. So you don't have to deal with it. Okay? -1 plus 2. So this was 2. -1 plus 2 is 1, correct? So now I have a 2, 1. If you chose the 1, you would have had -1/2 plus 2, and what would you get when you add those together? 1/2. Okay? It's just kind of what you choose to do. So do you have enough that you can graph it with 2 points? Graph it. But what you're going to hate about what we're doing right now, it's not that it's hard, it just takes time. It takes time, and that's what you're going to hate. Everybody does. Everybody's graphing it. Good job. The only thing you need to do is you need to label your axes so you know where those points are and then identify them. Okay? And let me see here. Good. Do you know where this Do you know where you got that to? Okay. Yeah, it's up there on the one up there on the podium thing. The only thing you would need to do for this graph you can take is you can always label your points on the graph. And always label the axis. Okay? Always label the points, always label your axis. I've been to the high school. I know from what I've seen from the math teachers up there, that's what they're going to expect. Am I right? Huh? she's been there, as a student, more recent than I have. They're gonna expect labels on these graphs, or you're gonna be missing points. Label the axis, label the points. So in this one, if I've got 0, 2, oh, I better. Zero, 2, and 2, 1. Okay, always label the axis, always label the points. Straight edges. Does your graph look like this? G. Always label the axis, always label the points. If you practice it right now and you have it in your notes and you're not doing that, when it comes to the assignment, you're not gonna do it there either. And if you don't do it, you will miss points. Okay. Now, let's just go straight to here. Okay. I'm going straight to this one. The other's the rule about it, but I want to graph x equals -4. Find a point on your line where x would be -4. If I say this is -2, -4, -6. Where is x being a -4? Where do I find it on the graph? Come here and show me it. Show me it. Show me where x is -4. Put it up there. Okay. Is there any place else where x is going to be -4? Now, okay, Olivia, I have a question. Is this x value, or is this a y value here? Okay? Somebody come and give me another point where x is -4. Okay? You're good. Look at what she's done. Is x -4 down here? Sure it is. Because if I come out x is -4, the fact that y is 0 doesn't mean a thing. Because it says graph x is -4. What kind of a line am I going to have if all I'm given is an x value? And it will always work this way. What kind of a line would I have? What's it going to be? Straight up and down, we call that a vertical line. Every time. If x is -4, you're looking at a vertical line. Always.
Who's boys? Boy.
Uh-huh.
Wouldn't the x also be -4
Yeah, a minute. Would you stop that machine? What did you ask me?
Wouldn't the x
just gonna be -4 everywhere along that line. Everywhere. Now, if all I'm given is a y point, what do you think that line is gonna look like to you? What do you think? Horizontal, good. So all I gotta do is find where y is 1.5. What if I said this is my 1.5? Half 1, -1.5. Okay? And I draw my line. Ah. I can't get mine. Okay, so I'll move you. There we go. Is y always gonna be a -1.5 on the horizontal line? Okay, that's what the slide ahead of this was. It was just telling you the rule there. Right there. Okay, the graph of y equals any number, therefore the b, is always gonna be a horizontal line, and it's always gonna pass through the y-axis at 0. Always. The graph of x, where x is any number or a, is always gonna pass through, through A0. Okay, it's passing, it's not really gonna intersect with that y-axis, is it? Because it doesn't exist. All right? There's your assignment. Okay? And I gave you a small one. You have a little bit of graphing it through the math journal. And so I think if I remember right, they even set up the graphs for you as far as giving you the graph.